Think about how a brick house is built. It goes up one slow layer at a time, leaving seams and weak points between every single brick. Traditional 3D printing works the exact same way, layer by layer. But what if you could just flash a beam of light and watch the entire object materialize instantly? Hi, my name is Burhanuddin, and this summer I worked on turning that concept into physical reality through volumetric additive manufacturing. Instead of stacking layers, our system uses a technique called computed axial lithography. You can think of it as a reverse CT scan. In medicine, a CT scanner takes a 3D object and breaks it down into 2D slices. We do the exact reverse. We take a 3D digital model and use advanced mathematics, specifically the radon transform, to calculate how light needs to wrap around and project into a spinning vial of liquid resin from every possible angle. My research focused on building the physical bridge between the complex computer math and the real world. I engineered a custom optical setup in the lab using durable thermoplastics to design specialized mounts in light shrouds that locked our projector and lenses into precise alignment. Then I wrote an integrated Python, MATLAB, and Arduino code to seamlessly synchronize the motor, cameras, and light patterns in real time. The result of the hardware and software integration is incredible. When those intersecting light beams hit the resin, they cross a precise energy threshold and the entire 3D object solidifies at once in a matter of seconds. There are no layer lines and no structural weaknesses, just a smooth, flawless, solid piece. By refining both the hardware and the optical setup, we are stepping closer to a world where manufacturing is truly instantaneous. We aren't just printing objects anymore, we are printing volumes in a flash. Thank you.